As you can see, there's a lot going on coming up in Lab 200L. Please note though, there is kind of a string of activities. That means there's a break from writing lab reports. So it'd be a good chance to review how things have gone with writing lab reports and to get ready for the future schedule. So you can see on Monday there are 2 lab activities that you're assigned. There is that one post lab still out there that's due on Wednesday. Please note you can see me during office hours on Zoom for talking about lab reports, talking about activities, all of that. So I hope to see you there. Generally, we set aside this time for lab report follow-up. What that means is you've been given grades, comments for experiment 1 and experiment 2 and most of experiment 3 now. So you want to follow up and get feedback on how to improve, what things are missing. I also want you to note what you've been doing is writing scientifically. Well, if you look at my website, you can see publications of journals that I've done, my dissertation. These are just more versions of scientific writing. A journal article will have an introduction, it'll have data observations, it'll have discussion. A dissertation is just hundreds of pages of those things. So what you're doing in this class is preparing for more scientific writing in the future, if that's what you choose. So the schedule, activities 8, 9, lab report follow-up, activity 10 on Wednesday. So what we're going to do today, go in great detail, I'll give a couple of examples of the activity 8, and then activity 9 is a really short activity. The main key while we're doing this, because it comes a little early, but this is review on naming. So naming is on exam 2. Naming has been in these lab activities, so we're going to review naming and then also start to balance. All right, so the first thing is generally in my labs, I'll give a quote lab report quiz. What I mean by that is I'll have you put everything away and say what goes in a pre-lab, what goes in data observation, and what goes in a post-lab. So I want you to be familiar with these sections, be familiar with the components that make up those. So then you can, as you're writing these, oh yeah, I need sources of error to go in post-lab. Oh yeah, I need qualitative and quantitative for data observation. So that's the hope, is that you'll feel confident in what is in each section. As I mentioned, comments and grades are out there, so see me during office hours if you want to talk about those. And can't emphasize enough, but you're using computers and labs, you're using lab notebooks, but one of our main objectives is for you to write scientifically. That's the hope in CHEM200L. All right, so we'll look at activity 8. First thing we're going to do is go over the boxes. So Lewis structure, draw a Lewis structure. You've done this in lecture. This is a drawing of the molecular structure in class. Some people have very nice drawings, some people maybe not as nice, but this is the representation of the molecule. And then the name, this can be confusing. There's 2 things here, the electron geometry and the molecular geometry. Angles, and then is it polar? Your lab talks about polar or non-polar. I want you to know if it's a polyatomic ion, you just say ion. You don't have to say is it polar or non-polar. So we'll go through this NF3, and if you take a look, steps, how many valence electrons? There's 5 for nitrogen and 7 for each fluorine. So that gives us a total of 26 electrons. Okay, Lewis structure, you determine which is the central atom. That's the least electronegative. So that would be nitrogen in this case. And we draw the terminal atoms. And remember, fill those octets first. And count it up. We have 24 electrons filled with the octet. That means we have extra. It would go in on the center atom. And if you take a look now, you add up, everyone has an octet, and it gets us to 26 electrons. So here, I'm not concerned with what this looks like in terms of 3D shape. I'm just drawing a good Lewis structure. Now, when we actually want the shape of the molecule, we have to actually go to this next box. So What we're going to do for this next box is look around nitrogen and see that's 1, 2, 3, 4 electron regions. So the electron geometry, that's tetrahedral. Okay, so that's 4 electron regions, tetrahedral, and we're being specific. That's not the molecule's geometry, that's the electron geometry. Okay, molecular geometry then accounts for this lone pair, and that's trigonal pyramidal. So we're distinguishing between what's the shape of the electrons and what's the shape of the molecule. So now we know it's trigonal pyramidal. We can go over here and draw that as a trigonal pyramidal. You don't need to draw the lone pairs here because we're just looking at the molecule. What is the shape of the molecule? Bond angles, that's specific for each electron geometry. So electron geometry of tetrahedral is 109.5. And because there's a lone pair over here on the top, that actually makes this smaller than 109.5. That squishes down these bonds, if you will, to make it smaller. That's 109.5. Polarity, we have to go back to electronegativity. So you look up the electronegativity values, and it's 4 for fluorine, and it's 3 for nitrogen. So remember, we have to determine, do we have a polar bond? So the difference in electronegativity is 1.0. That's greater than that 0.4. So that's a polar bond. And then if we go back to our molecule, those bonds are all pulling away from the nitrogen. Nothing cancels. So that's a polar molecule. Polar bonds that don't cancel, polar molecule. So I'll do another example. This is formaldehyde. So that's 4 for carbon, 1 for each hydrogen, and 6 for oxygen. That's a total of 12 electrons that we're working with. And remember, hydrogen will never be in the center. So carbon is in the center, oxygen's more electronegative, and we take care of the outer electrons first. And if you take a look, we've got 12. So if we filled in 6 here, we would have 6 here, but we don't have an octet around carbon, so we need a double bond. Now it's 2, 4, 6, 8 around oxygen, 2, 4, 6, 8 around carbon, and that's a total of 12 electrons. So if we go over here again, electron geometry, in this case, 3 electron groups. Okay, and really want to emphasize here, the 3 electron groups, it doesn't matter if they're lone pairs, double bonds, we're just saying how many regions of electron density there are. So there's 3, that's trigonal planar, and look, trigonal planar is different than trigonal pyramidal, so you have to really emphasize what you're talking about. And in this case, there's no lone pairs, so that means we also have trigonal planar. So no lone pairs, the electron geometry and the molecular geometry are the same. And now we can draw this, and sometimes you'll see double bonds in the molecular structure, sometimes not, but we're not including the lone pairs, we're just showing the shape. So this is 3 regions spread out as far as possible. That's 120 degrees. And again, because this is a double bond, it'd be squeezing this a little bit more. So it's less than 120 degrees. For the polarity for this one, it's a little bit different because you have to think about the polarity of the CO bond and the polarity of the CH bond. Okay, so carbon electronegativity is 2.5 and hydrogen is 2.1. So that's a difference in 0.4. That's a nonpolar bond. Here, oxygen's 3.5, so the difference in electronegativity is 1.0. That's a polar bond. Well, wait a minute, the question says, is it polar or is it nonpolar? Well, this bond is polar. This bond is nonpolar, so we got to go over here, look at the molecule. That's pulling in that direction. Nothing's pulling here and here. So overall, this is a polar molecule. So you'll have several examples to do this in Activity 7, page 77, 78. You'll have good practice on this. Actually, sorry, that was page 83, 84. Come see me during office hours and we can talk about Activity 8. This is really great practice for exam 2, so I really encourage you. I know it's only worth 3 points, but the practice will really prepare you for exam 2 in lecture. All right, Activity 9. So this one, like I said, is a really short activity, but the review here is naming. That's on exam 2 for my lecture exam. Okay, so we've got naming, review, great, that's helpful. And then it's going to bring up balancing. So this will come later in my lecture, but balancing comes from the law, conservation of mass. So we've seen that in lecture. That's why we balance. We've talked about states of matter, and we're going to emphasize writing a chemical equation accounting for all of this. So if you look at the name, tetracarbon decahydride is our naming scheme, but really organic chemistry has a different naming scheme. They would call this butane. So that's C4H10, and we put all the information that we have. This is the gas, because it's the butane and oxygen gas, and this is oxygen, so that's a diatomic. And that produces the gases water and carbon dioxide. Okay, so conservation of mass, we look and we say, wait a minute, I've got 4 carbons on the left, so I need 4 carbons on the right. Okay, so subscript 4 tells you how many there are here. So the way we balance is you put coefficients, goes out front. So that 4 goes to 4 carbon. It also goes to the oxygens, and we'll come back and talk about that. 10 hydrogens, so if we have a subscript of 2, we need a coefficient of 5 here. So now this 5 times 1 is 5 oxygens. This 4 times 2 is 8 oxygens. So that's 13, and we have a subscript of 2. So you could put a 6.5 in here, but if you've been in chemistry, you might be a little uncomfortable with that. Usually we don't do that, okay? So account for that one as a 1, and if you just multiply everything by 2, then you've got a nice balanced chemical equation. One thing to note is later on in chapter 9, you will actually see fractions or decimals in balanced chemical equations, but in this chapter, in this activity, and early in lecture, you will not. You want to multiply everything out so you get whole numbers here. So that's activity 9. Like I said, you'll get some practice balancing, you'll get practice names. This is a good quick summary of this information in activity 9.